Hi everybody. Today we are going to talk about polygons. I have a couple of really cool videos I'm going to show you that you have access to on your Schoology assignment today that are really fun, and we'll play the song throughout the week. So today is 9.6 polygons. I can classify polygons by their sides. So let's talk about the definition of polygon. Polygon is a closed plane figure, which means that it's not 3D, formed by 3 or more segments. So is a circle a polygon? No, it's not. It is not formed by 3 or more segments. It's one and it has curved lines. And segments cannot have curves in them. So it can't be like an ice cream cone with like the ice cream on top. It has to be a triangle. So I purposely drew these really wonky looking sided figures. You've heard of these. We've done a lot with our red hot root words that you should know some of these. Tri means 3, triangle, quadrilateral, pentagon, hexagon, and octagon. This one didn't turn out quite as well as I would have liked, but I drew these wonky on purpose. All you have to make a triangle is 3 line segments. Quadrilateral, it doesn't need to be a square or a rectangle or a parallelogram. It just needs to be a 4-sided figure. Same thing with a pentagon. This looks a little wonky. We always seem to draw those equal-sided things, and we'll get to that in a minute. Here we have 1, 2, 3, 4, 5, 6 sides. It's kind of a funny shape, like a misshapen spaceship or something like that. It is a hexagon. It is a closed figure, and it has 6 sides. Now the lengths of the sides are all weird. This one is 1, 2, 3, 4, 5, 6, 7. So I don't know, it looks like some sort of a badge or something like that. That's a septagon. Sorry. You will not need to know that one for the test. An octagon is the 8-sided. I was thinking of our video when I was making our notes, and they go through nonagons, which are 9-sided figures. And an octagon too, you just need 1, 2, 3, 4, let's do 5, 6, 7, 8. Like, oh no, it goes in right there. Doesn't matter, as long as it's a closed figure. What does matter is if it's a regular polygon, that's when the shape has to have equal length sides and all the angle measures have to be equal. So when we are talking about a square, that is a regular polygon. I'm going to show you a couple of pictures because Mrs. McKinley trying to draw these regular polygons ends up being a little bit of a mess for me. When we look in your book on page 486, you're going to see this figure, which is a regular polygon, and it should be an octagon. This is the regular one, and notice this one has those long lengths on the side. That is not regular. The sides are not the same, and likely the angles are not the same. When you look at their examples of classifying these, the first one is a rectangle, and although all 4 angles are the same, the sides are not. A rectangle is not a regular polygon. This one is a hexagon, a 6-sided figure with 3-inch sides, all the same, and you can see the little rainbow things here. Those mean that they're all congruent, the angles, and so this is a regular polygon. One only has to quickly look at this one, and you can tell 1, 2, 3, 4, 5, 6. It is a hexagon, but it is not a regular hexagon. You can tell by the length of the sides. Okay. I'm going to go below and just take a quick look at this one. You have 1, 2, 3, 4, 5. This is a pentagon. It truly is. 1, 2, 3, 4, 5 sides. It's a closed figure. But notice the angles are not the same. So this is an irregular or a not regular pentagon, where this one we have 8 sides, all the same. You see the little tick marks here, that means the same length sides, and all those little arcs right here, all the same angles. This is a regular octagon, which is like a stop sign. I know it's not showing very well on the stock cam, but you can definitely take a look in your book. One really awesome thing I wanted to go through with you, and this is what gets me really excited about math, is the sums of the interior angles. So we already talked about how all the time a triangle is 180 degrees. And we already talked about how all the time a quadrilateral is 360 degrees. And I'm going to take just a minute here to show you why this gets me really excited. So I'm going to push you all and say maybe try that challenge assignment because this piece is on there. So there is a formula you can use to find out the measures of the interior angles. This will be required next year when you get to Mrs. Wilson's class. It's in her curriculum as required. This is supplementary, which means it adds to the depth of my curriculum, but I think that you will enjoy the explanation here. So the formula here is n minus 2 times 180, and n equals the number of sides. So if we took the number of sides of a triangle, that's 3 minus 2, and then we multiply that times 180, watch what happens. Well, 3 minus 2 is 1, and anything times 1 is itself, so that is 180 degrees. Let's take a quadrilateral. The number of sides of a quadrilateral, well, that's 4. So if we do 4 minus 2, and then we multiply that times 180, 4 minus 2 is 2, times 180 is, lo and behold, 360 degrees. I want to show you why this works, and then we will go through what this is in a future lesson. I decided to add another and this is in your book, you are required to know this, what a diagonal is. A diagonal is a segment other than a side that connects two vertices. And I'm going to show you how to do this. So if I were to take just pick one corner of this quadrilateral and make as many triangles as I can with just one vertice, there are 2 triangles. Okay, I want you to take a look at the top of this pentagon. We're going to have that be the place where we find how many triangles exist in this shape. And we are going to go down here, and we are going to go down here. Notice I can't go here or here because it's already a side. So let's see how many triangles that we've made. We've made 1, 2, 3 triangles. Isn't that funny? It's the number of sides minus 2. Let's try it with our octagon here. So I'm going to start, I'm going to go 1. You can pick a vertice and you go from that one vertice. So I have 1, 2, 3, 4, 5, 6 triangles form to make up this octagon. So there's 6 triangles here. There's 3 triangles here, and there's 2 triangles here, and obviously a triangle only has 1 triangle. So what this formula is actually based on is picking one of the vertexes of the shape and going from there to seeing how many triangles exist in that shape. So conceivably, if you had a shape that was say 72 sides, and I will let you use your calculator for this, although you wouldn't really need to, what would be the measure of the internal angles if it was 72 sides? Remember, this is your n minus 2 times 180. I'm going to pause the video, and in addition to this, can you find the measure of the angles of a pentagon, a hexagon, and an octagon. All right, so here are the 72 sides. This one you could use a calculator. These you don't. You plug it into the formula. So 12,600 degrees in a 72-sided figure, 540 in a pentagon, 720 degrees in a hexagon, and 1,080 in an octagon. I hope you enjoyed that, and I hope you enjoy your assignment today. I think geometry gets really fun the more you combine it with the actual mathematical calculations.